Hello and welcome to the, what is this, November Java meetup group. And today we have a joyous presenter, Josh Long, and he's going to be reviewing the reactive resolution. And so, again, welcome to the Kansas City Java user group. We like to thank our sponsors, IBM, VMware Tanzu, and YRC Freight for giving us a spot when we can go to a spot. And we got Java News. Java 16, JDK 16 features in development. OpenJDK migrated to GitHub. That was successful. Support on Alpine Linux. An instance of pattern matching out of preview and records out of preview. So these features were in preview. You had to put a special JVM switch to get them enabled, but now they're enabled by default. Here you can see what Java Records is. It replaces the entire left screen with the right side. So you can see you can create just a static XY and a point, and you don't have to do anything. You don't have to do the equals hash code toString. It's really, really nice. And releases. We have a Spring Boot 2.4.0, which has Java 15 support, and also Gradle 6.7.1, which has Gradle support. Other news, we got JLove, which is December 4th and 5th. It's virtual and free, and you can go to jlove.confi.care to learn about it. FutureWorks Tech Conference, which is also virtual and free, December 9th through 10th. At FutureWorks Tech Conference, and Dev Nexus it's February 17th. It's virtual and free, and it's at devnexus.com. Local meetups, we are not going to have a video in December, but in January 21st, we'll be welcoming Angie Jones, and she'll be discussing some of the new features that are beyond Java 8. I know a lot of us are still on Java 8 or before, and it's good to preview what's coming and encourage you to upgrade. And is there anything we missed? If you'd like to get involved, you can attend meetups, tell friends about this presentation. You can like and subscribe to our YouTube channel, suggest topic speakers and locations, volunteer to speak at papercall.io.kcjug, or follow us on Twitter, or provide feedback at that address. And with that, this is Josh Long. Hey, Josh.
Hey.
So, Josh will get started. I have a special place in my heart for Josh because he gave me a hug. He gave me a hug because I work for IBM, and I really appreciated that hug. And I'll always remember that hug at the bar. So maybe when the pandemic's over, we'll do something.
Oh, I miss hugs. I miss whatever that was that we used to do before this. This time.
All right. Well, I hand it over to you.
How long do I have?
As long as you want, really.
All right. Good stuff. Good stuff. Because I got a bunch of stuff I want to, try out. I appreciate that, and yes, I hope we will all get past this moment in time, this unique moment in time. There's better days ahead, surely. And in the meantime, a little bit of software to keep us busy. Never hurt. So appreciate you all joining us tonight and today. I'm sorry that I was so late. My assistant put the thing at 5 o'clock PST or PDT, right? So California time, and I'm in San Francisco. And anyway, I'm so sorry. I am late. I didn't mean for that to happen, but we made it. We got it working. And actually, I was just talking to the reason I was caught unawares. I was in another meeting when my friend Billy reached out to me and said, "Hey, are you doing the KC jug?" And I was like, "Yeah, that's in 2 hours, right? Yeah, I'll be there." And he's like, "No, it's right now." I'm like, "Oh." So but I was in a meeting with Bruneians, people from Brunei, and they have great barbecue there. And so I was really excited about that. And then of course, Kansas City has great barbecue as well. And you can see the problem here in California. We don't have good barbecue. We don't have barbecue. Let's put it that way. We have there's some good Brazilian barbecue, right? But that's basically it. There's no real proper like burn ends or anything like that. And so as happy as I am to see you all today, and I'm hoping you're all healthy, happy, and safe, and all that. I wish we could have been there in person, safely, of course. And I wish I could get barbecue. And I just want you to know that I'm going to be hungry. I'll be salivating through the entire time we're talking tonight because I'll be thinking about barbecue. So, indulge me. Now, friends, my name is Josh Wong. As was just well explained, I work on the Spring team. I'm a Spring developer advocate, a Java champion, and a Kotlin Google developer expert. So, I think those all basically mean the same thing, which is I talk about these things a lot, right, in one way or another. And I'm at your service, first and foremost. I'm at your service. So should you have questions, when ineluctably you have questions, don't hesitate to reach out to me. I'm on Twitter, of course. I'm at your service there. Send me a direct message if you'd like, or via email, josh@joshwong.com, again, at your service, as always. And of course, we're going to go through a lot of stuff today. So most of the code, but not all, because I've got I want to switch it up a little bit since we have a little bit more time. Most of the code is there at Cloud Native Java 2020. I'll probably upload whatever we do extemporaneously. I'll upload that as well. I work on the Spring team, and I have for many years. I've done some training videos. I've got a book I wrote 3 years ago called Cloud Native Java. I have a podcast that I do every Friday, which is just me talking to people that are smarter than I am. Again, very low bar, but the people are surprisingly awesome, right? So really, really awesome, despite me, basically. It's just that. And actually, this is one of those things where I started the podcast years ago with the insight that it would be really cool to have a chance to turn the microphone and record these conversations that I'm having with all these amazing people. Wouldn't that be neat? And now, of course, in the era of the pandemic, it's just been really a blessing to have this opportunity, to have this excuse to force a conversation with really smart people, because I'm certainly not on planes at the moment, right? So either way, I'm grateful for this podcast. Hopefully you'll enjoy the conversations and as I do, learn something as well. This Week in Spring is a thing I do every Tuesday. That's 2 days ago, for those of you not keeping track. It's just a roundup of all the news that's fit to reprint in the ecosystem from every walk of life, every corner of the ecosystem. So videos, tweets, blogs, articles, whatever, right? All sorts of stuff ends up in this aggregation from the Spring ecosystem and beyond. And of course, I have a screencast series that I do every Wednesday, which is just me at the keyboard exploring some bit of Spring arcana. And I do this in seasons of 11 episodes and then a wrap-up episode. So there's an interregnum between seasons. Right now, we're in such an interregnum. But that said, as soon as the new season comes out, you'll see a bunch of stuff. And that new season, by the way, tons of Kubernetes. It's a Kubernetes-tastic season, so stay tuned. Spring in Kubernetes, of course, but Kubernetes is the star. And of course, I've got my new book called Reactive Spring. See this Reactive Spring logo cover, synergy. I have a book. It just dropped 2 months ago. You can buy it now. It's finished. It's awesome. Well, it's reactive anyway, and lots of stuff there. And obviously, I'm a big fan of the book. But that said, if you let me talk long enough, we might actually cover most of what you need to know tonight. So maybe I'm not doing myself any favors. Reactive programming, and indeed all of what we're going to talk about today, is at the end of the day motivated by my hope that we can build software destined for production that is resilient or tolerant of the potential sort of riskiness of production, right? And so there's a lot of patterns and primitives that fall out of that use case. And so, if you've heard me talk about Spring Cloud before, I'm going to talk about some of that stuff tonight as well, then you've no doubt heard me talk about patterns and primitives that are required to support building more robust, more resilient services. Can you hear that fire alarm? Isn't that crazy? I'm in a skyscraper high, like 12 floors or more off the ground, and I can still hear road noise off the side of the street there when it's high pitched. Anywho, what's going on? Oh, it's a fire truck. That's the thing, I'll never get used to. I'm presenting to somebody and there's a fire truck blaring right next door to me, which is strange. I have triple insulated windows, so I don't hear anything unless it's like one of those high-pitched sounds. But when you can hear it, you can really hear it, Anywho, reactive programming, and indeed a lot of the other stuff that we're going to talk about today is motivated by the need to make our services more responsive, more robust, more resilient in the face of the potential topology changes and the volatility implied in a production environment. And so reactive programming in particular, I think complements a lot of what I've talked about before in terms of Spring Cloud, because it gives us a way to say, to address three concerns that become obvious only when you start doing a lot more distributed communication at scale, right? The first concern is I want a cheap, easy way to create and reuse threads, right? I want to make better use of threads on the operating system, right? This is important, right? Because threads at the moment are expensive. Obviously, Project Loom looms, and Project Loom is going to be awesome because it's going to give us a lightweight thread scheduler, a lightweight virtual threads, right? I can't wait for this. I cannot wait for Loom. Loom will make it so that now the JVM can create, conceptually, millions of little virtual threads or green threads or lightweight threads or whatever we're calling it. I think it's virtual now. That's the first thing. But even there, Loom can't solve everything. So one of the things that it's going to do is it's going to make it so that the input stream and output streams and all the other blocking network APIs are not blocking behind the scenes. That is to say, whenever they're not doing something behind the scenes, they free up the thread and they return the context to the caller and allow something else to proceed. But that input stream still has a weight. It's actually heavy in RAM. And so actually, if you're doing input streams and output streams, and you've got lots of green threads, even though it's not blocking, the cost of keeping those input streams will be prohibitive to the point where you're not going to be able to actually have as many green threads as you're going to be bottlenecked by your number of input streams and output streams, right? The ability to do that is going to be a problem. So it's still going to be worthwhile to embrace asynchronous I/O there and to embrace a reactive API. But that's all neither here nor there. That's just the first thing that reactive programming gives me. The second thing it gives me is an ubiquitous domain model, an ubiquitous computational metaphor that I can use to describe data that I'm going to be consuming over the network, over the wire, that is potentially unbounded, potentially latent, potentially asynchronous, right? And then the third thing it gives me is consistency. You see, when you move to reactive programming, for better or for worse, it's kind of an all or nothing proposition. You can use non-blocking API, you can use blocking APIs if you want, but keep in mind, you're going to have to be very explicit about sort of isolating that code so that that has its own thread pool and it doesn't interfere or monopolize the threads being used by the non-blocking reactive code. And the result of this is consistency. When you move to reactive APIs, because there's only one kind of thing, there's not 10 different metaphors to describe 10 different asynchronous ways of saying, here's an asynchronous stream of data. Because you've got one kind of thing, life becomes easier. Life becomes more consistent, more deterministic, right? It's easier to compose disparate streams and sources if they're all just reactive stream publishers, right? This is in stark contrast to the sort of, the diaspora of solutions that we see today, even in Spring, right? Spring for all of its time has been very quick to provide easy, simplifying abstractions for different models of computation, but they're still different APIs, right? Like, so for example, if I wanted to consume messages from Kafka, I'd have to create a Kafka message listener container, right? In the Spring perspective, it's usually at this point, given the component model, it's still like a method and an annotation and a payload. Okay, fine. What about RabbitMQ? Yeah, same basic arrangement, but it's slightly different annotation, different properties. Okay, what about JMS? Yeah, same basic thing, but different, a little bit differences there. What about service and events? How do I do that? Well, okay, that's different. What if I want to do websites? Yeah, that's very different, right? So what about if I wanted to do like, application JSON? Well, again, that's very different, both for the producing and the consuming side. When you move to reactive APIs, you have just one kind of stuff. It's not 5 different ways of saying, hey, thing that produces data is eventually, please do so now. It's just one way. You have one concept, one paradigm. So it makes composition, very, very nice. And especially in the context of a microservices environment, this becomes very useful for service orchestration and scatter-gather kind of service composition. So I'm going to talk about those 3 points today. I'm going to do so in the context, of course, of a microservices system. And everything I'm going to show you today is all about how to build software intended for production. So we're going to start small at the service level and build up to the systems level. And of course, we're going to do that by going to my second favorite place on the internet. Obviously, my first favorite place on the internet is start.spring.io. I love start.spring.io. You should love start.spring.io. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It is better than Disneyland. But if you have not been there, you can begin your journey here at start.spring.io. And here we're going to choose what version of what build tool we want, Maven or Gradle. I'm satisfied with Maven. Either one would work just fine. What language you'd like to use, Java, Kotlin, Groovy. I think we'll look at Kotlin later, but for now, let's start our journey with Java. And then, of course, we have the choice of which version of Spring Boot we want to use. 2.4 is a great version to park our code at. 2.4 has a lot of compelling features. Everything I'm going to show you tonight it has been around in some way in a generally available fashion for at least a version of the respective projects. The projects that we're going to use tonight are in some cases snapshots, but that's only because in some cases those projects depend on Spring Boot 2.4, and the version of 2.4 just dropped a couple weeks ago at most, so it's fresh out of the oven, so to speak. And so the new projects that depend on that haven't finished their release yet, but the features I'm going to show you have existed in earlier GA releases. One of the things that isn't yet GA that you could do with 2.4 that we're not going to linger too much on, but which I think is really tantalizing, is GraalVM support. So we have a project called Spring GraalVM. Now GraalVM is, of course, as you know, a ahead of time compilation mechanism. The native image support inside of GraalVM is a way to create ahead of time native images. It's also really convenient for building for a just-in-time compiler replacement. So the original sort of origin of GraalVM was that they wanted to replace the just-in-time compiler, the C1 just-in-time compiler called Hotspot, with something that was hopefully, fingers crossed, just a little bit less gnarly a code base, right? So Hotspot is a lot of spaghetti C++ code that has done the job, but it's now starting to get past its prime. So they wanted to replace it with something that'd be a little bit more efficient, something easier to maintain, etc. So they wrote a mostly Java C1 replacement called GraalVM, and this plugs into the OpenJDK, and even in just that capacity, it's interesting in of itself. But that's not why most people talk about it. What they care about is this weird little sort of experiment that ships with it as an extension called the native image builder. And what the native image builder does is it, rather than adaptively converting Java code into native code, as we see over successive runs, certain pathways being over-exercised, rather than doing that adaptively, what GraalVM can do is it can proactively compile everything into native code. Now, it's weird that I have to tap dance around all that and say it that way, because for every other language, when you say, I'm going to compile my code, for most other languages, when I say I'm going to compile my code, what we mean is I'm going to take the source code and it'll be a native image in a second or whatever, right? But in Java, when you say compilation, that implies taking my source code and turn it into bytecode, which is not yet machine code, right? So there's that.
Can I interrupt you? Can you zoom in to whatever, because with YouTube and yeah, thank you very much.
Thank you. Okay, so the point is, this is a very interesting pursuit, this native image support, very interesting opportunity for developers, but it's not without some costs. So the idea is that we can turn our applications into native images with this feature inside of GraalVM. A feature, by the way, which looks to be coming to JDK. They announced a project called Project Leiden, Leydon, and Project Leiden is a basically, I think, a rubber stamping of Graal. I'm not sure exactly; it's super early days yet, but I think the idea is to have a static native image mechanism inside the JDK proper. So, us as a community figuring out how to do native images today will be valuable later, even if we have to change the tooling a little bit, once it's part of the JDK proper. So GraalVM, the Spring GraalVM project is a tool. It's a framework. It's a mechanism that's designed to help you move a Spring application to a native image. And that's not the thing I'm here to talk to you about today, but I'm going to briefly show it to you because I really I think it's compelling. So I've got an application that you can follow along with at home if you're playing the home game. So WebFlux, Actuator GraalVM. Here's this code base. It's a project. It's a Spring Boot project. What do you need to know? Well, first of all, pretty trivial application. It's a Spring Boot application. The only impact in my code is that I'm using proxy bean methods equals false. I had to do that. And otherwise, it's a reactive application that when the application starts up, we have a repository, we create the database table. I'm using H2, the in-memory embedded SQL database. Were I using Postgres or something else, then this application would no doubt be even faster. But since I'm starting up the database server in the same process as my Java application proper, you'll see that reflected, unfortunately, in the slow start time. Then I'm gonna create the table, then I'll save all the data, then I'll find all the records, then I'll print out everything there. Basic pipeline, basic reactive API there. I've got a reactive data repository. I've got a reservation. I've got an HTTP endpoint. And I've got some endpoints that have to do with the actuator, which we'll talk about later. So just a pretty trivial thing. What we need to understand about the project itself is mostly in the build file, right? In the build file, we have all the usual suspects, normal stuff. The only thing that's exceptional or noteworthy is the Spring GraalVM native dependency there. And of course, the optional, so you can do one or the other or both, but you don't need both. Optional config for the Spring Boot Maven plugin, where you can configure Docker image generation with native images, or you can have as part of your build process itself, you can have it dump out a native image, right? Either one works, both work, you can do both. So the point is, if I activated this Maven profile, then in my target directory, I would get a native application based on the code in this code base. If I used the Spring Boot Maven plugin, then what the result would be a Docker image in my local Docker registry that has inside of it a native image. So that gets you 2 for 1, whereas this mechanism gives you 1 for 1, right? But either way, they're both. You can use one or the other. You can do both, whatever. So let's try that out. I've already got that here. CD target, and I'm not going to sit here and recompile everything because it takes a minute or 2 minutes. But the result is. That you get an application. That's an application. You get a binary, statically linked binary that has everything inside of it that's required to run the application. So you don't have a second JDK anywhere installed. That's it, right? This binary is also proprietary to the machine. It's only going to work on Mac or only on Linux or whatever. And at the moment, there's no cross compilation as there is, for example, in C++ or Go. But that's okay. Most of us run CI environments inside of Linux. We're deploying to Linux. That's not really the big issue you should fret so much about. Okay. So I've got this application. Let's start it up. Okay. There's my application. So I want to allow it to accept incoming request. Yes, but thanks for slowing down my startup, you insensitive clod. Let's start it again. There we go. It's still not very satisfying. There you go. That's more typical. 0.135 seconds. Oops. 0.135 seconds. So there's my application. It's a reactive application that just talks to a database, which it's embedded, right? And it starts up in less than 1/10 of a second, basically. The real win here is not the startup time, because again, the startup time is only for the time you start it in production. And anybody who says that your process is faster at starting up than an already warmed up application is in responding, then that's a lie, right? It's impossible. It's not true. So it's never going to be fast enough for the scale from 0 to 1 case, but from the scale to 1 to 10 case or whatever, that's a very natural, manageable thing, as long as you've got one that can already handle the load, or that's available already, right? What I care about is not the startup time, even though that's really compelling. What I care about is the very small footprint, memory footprint that this implies. You get tens of megabytes of RAM instead of hundreds of megabytes of RAM, right? What is this process? No, sorry, activity monitor. That's what it is, right? Activity monitor.
Hey, Josh, we got a question for you. What is the get link for the WebFlux Actuator GraalVM?
Sorry?
What is the get link for the WebFlux Actuator GraalVM?
Okay, hold on. It's github.com /long WebFlux-Actuator-GraalVM.
Awesome.
So this application right here, WAG, is taking 71 megs of RAM. It's got 11 threads and so on. So it's nothing, right? That's the entire application. That's steady state will be about 71 megs of RAM or less. It might even go down, right? So really, really compelling results there. Great for deployment into production. And obviously, I'm doing this against 2.40 M3. The situation is even better now with Java, with the Spring Boot 2.4. So I wanted to mention that. I wanted to really stress that there's a lot of cool things in 2.4, but that's not what we're here for, so I'm going to move on, okay? Let's see here. Control-C. Okay. Goodbye to that. Goodbye to this. Good stuff. Good. Okay, so now we've got our application, and we also have the choice of what version of Java we want to use, right? Do you want to use Java 15, 11, or 8? Before you, my friends, we have 3 checkboxes, 3 radio buttons that imply a choice where I'm afraid there really is not much of a choice. There's actually only 2 choices. The third option, Java 8, is a non-choice. Non-choice isn't just an Indian bread. It's a choice that you could make, but that you should not make, ever. It's a terrible choice to use Java 8 today in 2021. Oh no, sorry, in 2020, but almost 2021, right? We're less than 2 months away from 2021. Are you prepared to be using Java 8 in 2021? I don't think you are. Friends, you have 2 very serviceable, very usable, very good choices here in Java's 11, which is the long-term support version of Java, and Java 15. These versions are technically more robust, more secure, faster, more scalable, etc. And then we also have Java 8. Java 8 is technically inferior in every way. It's technically less secure, less robust, less featureful, less syntax-rich in every way. It's also morally inferior in every way. Are you prepared for that discussion with your children when they find out that you're still using Java 8 in production? I don't think you are, friends. I don't think you're going to like the look on their sad little faces when their faces crumple in disgust at what they found out that their parents have been doing in production. Don't do it. Be the change you want to see. Use Java 15. Okay, so we're going to use Java 15. We're going to build a new application. And with this application, we're going to build a reactive web application. We're going to talk to a SQL database using the Reactive Relational Database Connectivity Abstraction called RTDBC. We're going to bring in Postgres. Postgres is a SQL data store that I've got running on my local machine. I'm going to bring in Lombok. Lombok's a compile time annotation processor. And I'm going to bring in a few other things. So we want Spring Cloud Stream for RabbitMQ, right? Okay, we want the configuration client support. We want the Eureka service registration discovery support. We want the Spring Boot actuator support. Okay, so we've got a lot of different things here for now. I'm satisfied with my selections at this point, but keep in mind you're free to peruse. There's a lot of different choices here, and so on. So I'm gonna go ahead and, having made those selections, I think I'm just gonna leave it there. Oh, you know what? We need RSocket. We forgot RSocket. Now I'm gonna hit generate. And we'll start up our application. CD downloads UAO customers.zip. I'm going to open this up in my IDE. Okay, as it starts up, it's going to re-index the world apparently, but that's okay. I'm going to go there and comment out a few things just before we get too far down the road. Comment out a few different dependencies that I don't need just yet. So Spring Boot Start Actuator, I want to keep that, but the AMQP bits, not yet. Okay, so let's see. Going from bottom to top, we don't need the JDBC driver. Thank you. Goodbye. We don't need AMQP or the Spring Cloud Stream Binder or Spring Cloud Stream, etc. Good. We don't need the config server or the Eureka Discovery client yet. So what we're left with are the RTDBC support, RSocket support, Spring Boot Actuator, the Reactive Web support, and our driver for our Postgres database. I'm going to go ahead and Maven reload this project, and then begin the work of actually building a service. And this service is going to talk to a data store, as you probably gathered by my use of a driver to talk to a database. And so in order to make that connection, I need to configure the connection string. So I'm going to specify a connection URL. Now I'm using something called R2DBC. Now R2DBC is a reactive relational database connectivity abstraction that will let me talk to a SQL database with ease, right? It gives me, let's see, 85. Is that legible? Hopefully it's legible. 26. There you go. Hopefully it's big enough. That's 30. I'll make it bigger if need be. Okay, friends. So I want to talk to an application database, and I'm going to use R2DBC. And there are drivers for all sorts of other databases. We just announced Oracle's driver. We've got drivers for Microsoft SQL Server, for Postgres, for MySQL, MariaDB, for SAP HANA, for H2, for Google Cloud Spanner, for Azure Cosmos. I mean, just all sorts of anything that speaks SQL. There's probably an R2DBC binding for that already. Lots of really interesting opportunities there, friends, to take advantage of this ecosystem. But this is not JDBC. That's the first thing to keep in mind. This is actually a reactive core SPI and a number of supporting implementations, most of which, by the way, are maintained by the respective communities. So, for example, we just finished a few months ago the handoff of the Postgres R2DBC driver to the Postgres community. It's under the Postgres GitHub org and all that stuff as well, right?
How many of those databases are reactive all the way to the communication?
All of them. We don't do reactive facades on top of non-reactive drivers, right? So
that's awesome.
They all support asynchronous I/O. That's what I think you're asking, right? They support asynchronous I/O, and so we build on top of that, which gives us the ability to do reactive programming, right?
Yeah. All right. And then IntelliJ, you're a wizard on what you do. Is there any plugins or shortcuts? Or Nihal wants to know.
I mean, there's what's that one? Shift. That's my favorite one. If you don't know what it is, just do Shift, and it'll give you a super finder, Uber search. And here you can search for anything, right? Including actions. So if you want to how do I commit or whatever, it'll show you where that command is in the menus. So other than that, I don't know. I think I have my plugin enabled. Do I have a plugin? I should have my plugin enabled here. So if I do, see that down there? It's green. Rename via F6, Shift F6. So it'll show the commands that I'm doing for you if you want them, if I use them. There you go. So reformat code. A lot of times I just reflexively reformat my code. You'll see that pop up a lot. Okay. So we've got our application. We're going to talk to a data store. We're going to build a domain model that's based on this idea of an integer, of a customer, and the customer will have a name. And so we're just going to get this data from the database. And this database, as I say, it's already running on my local machine in the background there. We're just going to surface that information through a repository. So let's make this a little bit larger. Here we go. PSQL, view orders, select all from customer, voila, insert, let's see what we've got here. Select all from customer, order by ID. Okay, so we're missing 1, 2, 3, 4, 5, 6, 7. We're missing 8. So let's insert into customer ID name values 8 Billy. Okay, there we go. And there's our equal, nice round 8 numbers. Is that right? 8 records. Good. So those are some names that we're going to retrieve from the data store in our trivial little service here. We're going to map those records to this DTO, this entity of sorts. And in order to handle the tedious, soul-annihilatingly boring read, write, update, and delete lifecycle management methods, we're going to pass all that work to a Spring Data repository. And this repository is just meant to make short work of all that data lifecycle stuff that I don't care about. So things like save all, count by ID, check if it exists, delete, all that kind of stuff is implied by this interface. You don't have to implement it. These methods are just done for you automatically. Spring will provide a proxy for you that you can use. That said, the parameter types might be a little interesting. The first of which is a publisher. A publisher is a thing that, publishes, right? It's built in. It's in the name. So it's a thing that publishes data asynchronously out of band to a subscriber. When the subscriber gets that, when the subscriber first subscribes to the publisher, it is given a subscription. We're going to talk to that point in just a second, but let's put a pin in the subscription for just a second. After we've been given a subscription, when data arrives, those messages, those records are passed in the onNext method. If there are errors, when intellectually there are errors, they are conveyed in the onError method. And finally, when the publisher is done emitting data for us to consume, the onComplete method is invoked. So these are the 4 lifecycle methods of the subscriber. But as I said, the subscription is, I think, of paramount importance. The subscription is what the subscriber uses to request more or less data of the publisher. Put another way, the subscriber can use the subscription to request, let's say, just for easy math, 10 more records. If the subscriber wanted another 10 records after it is exhausted, if it's processed those first 10 records, it can request as many more by calling request 10 again. Or it can say request -1, in which case it'll get all the records that are left over as fast as the producer can produce them. Let's say, however, that the subscriber has been processing the data from the publisher, and that data has just been nothing but trouble for the subscriber, and it wants nothing to do with it anymore, and so it wants to cancel the stream. It can call subscription.cancel, and that'll end up canceling the production of the data. These two things seem so trivial, but they're really, really important, right? The idea that me as a consumer, I can push back against the rate of production of the producer, the idea that I can slow it down so as to not be overwhelmed, that's critical in building reliable services at scale. Lots of different, I think in lots of different paradigms, lots of different aspects of the ecosystem, we appreciate the need for that ability, right? At low-level TCP UDP programming, you have to care about this. You have to care about what happens when one node produces data faster than another node can handle it. We call that flow control. And flow control is critical to building reliable protocols. At the systems level, forget about the low-level socket level, now at the systems level, we also have something like this. We talk about message queues, right? We introduce a broker like RabbitMQ or like Apache Kafka or anything else, right? Anything that gives you that store and forward architecture capability. We introduce that for the same reason, because demand gets serialized through the broker, and the consumer drains the broker as fast as it can, but no faster. It's impossible to denial of service a messaging consumer if we're draining the consumer at the speed that we want, right? So as long as you control how many threads are being created and what you're doing in those threads, you can just do one message at a time, or you can do only 8 at a time, but you'll never have 8 million records dumped on you and only 8 threads in which to handle it, right? They'll come off the queue when you're ready to have them, right? That's important because it ensures that your consumer doesn't get knocked over, right? It doesn't get overwhelmed or denial of service. So this ability to control flow at the systems level makes a lot of sense, right? We've all understood the concept and the motivation for message queues, and at the low level, at the protocol level, it makes sense. We all understand the motivation for that there. What we're doing here isn't therefore that novel. It's just that it's there. It's surfaced as part of the top level API. Now you can push back against the overwhelming data being produced by a publisher. This is called flow control, or sometimes interchangeably back pressure, okay? So when you hear the term back pressure, what we're just talking about is this very simple idea that at the protocol level, at the Java API level, I have this mechanism I can use to cancel or slow down the rate of consumption. That's critical, okay? Now, keep in mind, if you as a subscriber request 10 more records, there's no guarantees or prescriptions as to how quickly you'll get those 10 records. You might get 10 records in the next 10 years, right? You might get 10 records in the next 10 nanoseconds. You might get them all in the next second. So it's how much you feel you can safely handle all in one fell swoop, right? If you were to have it all dropped on you at the same time, could you handle it? If so, then put that number there, right? And if you're really not worried about there being an overwhelming amount of data, like for example, if you're just getting 100 records from something where it's a practical limit, right? There's no such thing as people with 10 billion friends on Facebook or something like that, right? It's not unreasonable. Then maybe you can just put that in -1, right? But the point is now you have that choice. These are 3 of the 4 critical reactive streams types. There's a 4th type, however, called a processor. And a processor is a bridge. It's a source and a sink, a publisher and a subscriber, a consumer and a producer. It's a bridge. And we'll see a processor later on. These 4 types are part of the foundational reactive stream spec. They're very foundational, though. I think we can agree. They're super simple. They're so trivial, so simple, in fact, that they've since been incorporated into the JDK. So we have, for example, Java util concurrent flow processor, Java util concurrent flow.subscription.subscriber, and publisher. These types are analogous, save for the namespace, of course, to the types in the org reactive streams package, and they're interchangeable. There's even a type in the reactive streams library called flow adapters, and it's the only concrete type in that jar, and it gives you the ability to convert one publisher to another, and back again. So very, very convenient. However, foundational. There's still some opportunity that's just not, there's just still some things I want to do that I just can't do yet. And so in order to support easy composition of data, to support easy processing of data, there are two specialized types I'd like to introduce you to that you can see reflected here in the signatures of the reactive CRUD repository. The first subtype is called a mono. A mono comes not from the reactive stream specification, but from Reactor. Reactor is the reactive data flow library from the Spring team. It gives you a way to describe pipelines or reactive pipelines, and it gives you two publisher specializations, the first of which is a mono. A mono is a publisher that produces at most one value, so 0 or 1. And this is a publisher that has a whole bunch of different operators. Look at all those operators. Whoa! We're gonna die. Okay, let's see. We're almost there. Are we there? There we are. We got it. 4,771 lines of code. That's not code that you want to write, friends. It's not. Don't do it. Be the change you want to see. Do the right thing. Use the framework. So we've got mono. In the other type that we have is a Flux. A Flux is a publisher that produces 0, 1, 2, 3, a billion, a trillion, or unlimited data. Right? It's potentially unbounded, and that's the point. It has all those same operators like map and flat map and switch and so on. But it also has this semantic implication, right? If somebody gives you, if you have a method that returns a mono of customer, then you know that that's only going to be at most one record. So you could do that for, you can imagine a find customer by ID. Either the record exists or doesn't, right? But it's only going to be one record. There's no, in a primary key, you only got one record, right? If they give you a Flux, then perhaps that's multiple results. Maybe you have a, Flux of customer search parentheses string query, right? And the query could return 0 records, or it could return 1,000. So the Flux would describe all of those results as they become available, right? So the signature, the semantics are important here. We recommend that you return reactive specialized types like mono and Flux, but you accept the base type publisher, right? So that you can be very, very compatible. Okay, so we have a repository, and now, I guess the first thing I want to do is I just want to print out the results. Application listener, application ready event, ready, return event. All right, and we're going to inject our repository here. Customer repository, CR, good stuff. I'm going to say cr.findAll, and all I'm going to do is I'm going to print out the results. Now, I could, and probably should, do more, but I could actually, for example, let's say I wanted to write some data myself. I wanted to say flux.just, let's do this manually. We'll write some other names manually, okay? So Yushin, Spencer, Madura, Olga, okay, Violetta, Stefan, Rob. What is that? Is that 7? 1, 2, 3, 4, 7. I need one more Spring team member. There we are. Good. Yes. So there's our stream of names, right? And I want to write those to the database. Okay. So I can say, okay, names, map, name, new reservation. Sorry, new customer. Passing in a ID, and the ID. Well, I want those to be 1 through 8, right? So let's delete the ones we've got here. Delete from customer. Okay. And ID equals new atomic integer. And this is only for benefit of my demo later. So I'm going to do ID.increment and get. Or I want to get and increment and get, and then I'm going to pass in the name. Okay. And then I want to save those to the database. So I'm going to say for each customer that I have, let's call that repository and call save, passing in the customer there. So the result will be that I have a stream of customers that I've saved to the database by calling save. And now if I run this code as is right now, nothing will happen. I need to actually, first of all, I need to force the evaluation of that data, right? And the way I can do this is by subscribing. Right? You saw me do that before. So names.subscribe, subscribe. Okay, I can do that. But the other thing is I want to also, after this has all been written, after all this data has been written, I want to get all the data and print it out. So here I can say all equals cr.findAll. So what I want to do is I want to write the data to the database. I'm going to first delete all the data in the database. I'm going to say var delete all. That gives me a mono avoid, so var delete. And then I want to write the data, and then I want to get all the data. Now, these are reactive types, each one of them. And if I subscribe, there's no guarantee on what thread they're going to execute, right? So I need to make sure that I do this in a deterministic way. I want one thing to happen before the other. So I can do that by saying delete, then many, write the names, then many, return all the results, and then finally subscribe. Okay, so I'm going to subscribe here and print out the results. Okay, so there's my reactive stream of results, and I'm going to ensure that one thing happens deterministically before the other. Hopefully this will work. This is the first time I've tried that atomic integer trick. Fingers crossed. Not so much. What did I do? Let's see here. Row with oh, it's update. Oh, so it's trying to do an update. Yeah. Okay, I guess I'll have to do this the old-fashioned way. Okay, so null. We'll let it automatically provide us the ID. The only problem is I think it's going to pick it from a sequence or something. Arg. Okay, well, there we go. There's our IDs, 85, 86, 87, 88, 89, 90, 91, 91. So I got to remember that for later. You'll see why. So there's our data in the database. There we go. There's our records in the database as well. So 85 to 92. It's worked, right? We've managed to write SQL data to the database using these reactive APIs. Not a big deal. We can also take advantage of transaction demarcation. So there's actually declarative transaction demarcation. And that works just the way you'd expect it to work given Spring. You just annotate it with @transactional. But what's interesting here is that we can propagate the state for that ongoing transaction, not in the thread local, because of course thread locals make no more sense in this wonderful world of reactive programming where the flow of execution can jump from one thread to another. Instead, you keep it in the context, which is a construct inside of Reactor that allows us to say, this data is available for the life of the pipeline, and I can pluck it out at any point in the pipeline and be assured of it being the same one that I started with. So we use this all over the ecosystem, all over Springdom for various things, for propagating the ongoing transaction storage, right? So for RTBC or Neo4j or MongoDB or whatever, we have an ongoing transactional state. We use it for authentication, right? So when you authenticate with Spring Security, we need to stash the principal somewhere so that it's accessible to downstream components in the system. And of course, that's a very natural place to do it as well. So when you make a request and you've got in the request body, you've got a challenge, credentials for a challenge, you authenticate. Where does Spring Security put that authenticated principal so that downstream components don't have to re-authenticate, right? It's already been done at the filter at the edge. Why do it again and again? So we use that context for that as well. And then, of course, with distributed tracing with Spring Cloud Sleuth, we use it as well to propagate the context associated with the current request. So all these things make good use of this context mechanism, and it's just transparent to you. I just wanted to point out that it's possible if you're wondering about that. And that's a general purpose mechanism that you can use, that context. It's not just limited to us. It's a public API. So now I've got data in the database. What else do I want? Well, I probably want an HTTP endpoint, right? So router function, server response, routes, turn route. Okay, and I'm gonna return the customers. And my job here is to return a handler function, and the handler function will, given a request, it'll delegate to my repository here, like so. So I'll say customer repository find all, customer.class, and voila. Okay, so there's this. Replace that with Lambda, great. Replace that with a static import, great. And replace this with a request, even better. So there's my whole HTTP endpoint. That one line is my HTTP service. It's the predicate, the URI, and the handler that produces the response. And of course, this is a fluent API, so you can chain together other endpoints. You can put them all together. You can, and the nice thing is you got all your routes for your whole application in one place. You could use a Spring MVC style controller annotation model where you have at controller on a class, or at request or at risk controller, and you can have mapping annotations on each method. Or you can do this, or you can do both, as long as you don't have overlapping mappings, right? You can't have both a functional reactive mapping for HTTP GET to / customers, as well as the Spring MVC style controller mapping for HTTP GET to / customers. So I like the style. You can also use while loops and for loops, and you can talk to databases and do whatever you need to, and then dynamically register endpoints based on your use case. All that I think is pretty nifty. Now, I have my HTTP endpoint. Let's go ahead and start this up and see what we get. Oh, port 880 is already being used. Of course it is. Take 3. Okay, there we go. Localhost, customers, and voila. There's my data. Very good. So I've got data talking to a database. I've got an HTTP endpoint. I think I'm ready to go to production. And at this point, there's a lot of concerns that I care about when it comes to being ready to go to production. The first thing I care about is configuration, right? So thus far, I've put all of these properties, these usernames and passwords, these credentials that really shouldn't be in my hard-coded property file. I've put them here in the hard-coded property file buried within my source code. And this violates, of course, the principle of 12-factor style configuration, where you keep any external configuration outside of the application binary. Because if somebody open source your project right now, we say, would they find anything that would allow them to access production? In this case, they would, right? They'd find the password to my production database. So I want to keep that external to the code so that I can swap it out without having to recompile the code. And Spring Boot supports a number of strategies for this. This might actually be, in point of fact, my development credentials, in which case it's fine to just leave those there. But I still want to be able to override the password externally. So you can use environment variables, for example. And that's very convenient because if you're using Kubernetes, you can create a config map and then create an environment ref that maps to that config map. So all the keys in the config map become environment variables in the environment of the running pod. That's very convenient, right? I like that. There's also another kind of use for config maps, which is as a config tree. So the idea here is that you've got a directory full of keys which are the names of the files, and the values are the contents of those files. And so, for example, if I wanted to have this password, right, drawn from a config tree for Kubernetes, like such as this one here, but this is just a directory, but you can see spring.rtgpc.password orders. I need to be able to point my Spring Boot application to do that, and I can do that now in Spring Boot 2.4 with this new thing here called config tree. So home, desktop, config / very important. So I'm telling it to import the configuration. There's now a scheme. There's now a scheme handler mechanism for configuration sources. We've always had the ability to plug in multiple configuration sources in Spring. You can talk to the Spring Cloud Config Server, or to HashiCorp Vault, or to Console, or Zookeeper, or whatever, right? Alibaba has something called Registry, I think, Alibaba Registry or something like that, and that's confusingly actually where they keep the configuration. It's not the service registry, something like that. Or maybe it's called config. Maybe I'm thinking it's the other way around. Either way, they've got something that you think it's for one thing, but it's the opposite. And that thing also does configuration. It's the same idea. Well, now we have an abstraction, right? We have a proper mechanism for people to extend in a predictable way the possible configuration values that are available to your application without stomping at each other and while maintaining a deterministic sort of ordering. Okay, so here's this. Let's now restart the application. If it still continues to work, then we know that worked, right? That's very good. Okay, so I'm getting the password from somewhere because I'm not specifying it anymore, right? So that's good. I want to see this information. I want to see what information is in my application. So of course we can use the actuator, right? So I'm going to expose all the actuator endpoints. The actuator are a set of managed HTTP endpoints that Spring Boot provides that surface information about the service proper for the consumer. And these actuator endpoints they give you information about the service itself. So the health, the uptime, the metrics, things like that. Things that you need that go beyond what your container platform can see. Case in point, one of the telltale signs that you really need reactive APIs is when you log into your data center or you log into a service and you look at the uptime, you notice that for the most part, your CPUs are mostly idle. And yet, in some cases, you can't even get another request in, or it's slow to respond. This is the problem, right? Because what this says is your service is blocking. You've got too many threads that are parked in a wait state, waiting for the next byte to arrive, and they're unable to move forward, but there are no more threads, so no traffic is getting through. And yet, from the perspective of your operating system and from your container manager, your CPU is almost nil, right? You're idle. So everything's fine, right? Surely. There's no reason to kill that pod. It's fine. It's healthy as can be. This is a problem, right? There's a disconnect, a dissonance between what's the actual state of your services versus what the low-level machine can see looking up into your code, right? So the actuator is a great place to articulate, hey, my queue depth is too high, for example, or I've got no available threads, or I've handled 5 requests in the last hours, and therefore something's wrong, right? Because we've definitely had more than 5 requests, or something like that, right? The actuator also, in that, very useful to know, it has its own thread pool, so you can't exhaust the actuator with the same threads that are overwhelming the rest of the system. So the actuator is very useful.
Hey, Josh, I have a question for you. What happens if in the delete command you had before, and then you call then many? What happens if it fails?
In the where?
You had the 3. Yeah, sorry, this is way back. That delete and then many and then many. The question is, what happens to the delete if the command then many fails?
Oh, if you've got it wrapped in a transaction, you can roll back. If you don't, then you'll get an exception in the pipeline, and you can describe how to fail or how to respond or whatever, new runtime exception, etc. And you handle that not with try catch, but with on error, right? An on error. There's a bunch of on error variants here. On error, whatever. On error resume, on error map, on error continue, on error stop, on error back pressure, etc. So you can control how it degrades. But basically, you're going to get an error, and your job is to turn that error into a deterministic step forward.
All right, thank you.
Cheers. Good question. Okay, so I've got my actuator endpoints. The last thing I did was I set up my endpoints to enable the health probes, and we're going to talk about that in just a second. So let's restart the service. Okay, so the application is up and running. Up here, customers, good stuff. Now I can go to actuator, and I can see all sorts of interesting things here. Metrics, for example, gives me.
You want to zoom in, please?
I just did.
Thank you.
I can see, for example, how many requests have gone into my application, for example, and it shows me the details, the counts, the statistics, all that kind of stuff, all the tags, the dimensions of the attribute. So this is in stark contrast to regular, key value metrics stores, right? For example, Grafana. This is dimensional metrics or hierarchical metrics where you have tags, you have the core metric, and then you have dimensions of that metric. So you might say, how many requests have I got? Well, that's a metric, but how many requests were for the HTTP GET endpoint? So you can actually build up a predicate question, or how many of them had an exception, or how many of them went to this URI. So you can say, I want to know how many requests I got, where the outcome was success, and the status was 200, and this, and this, and this, and this, right? So that's all stored in one metric. And it's much easier for a database to store those things together and for us to query them together, right? For a time series database like Prometheus, which is very common in the Kubernetes world, right? Or Atlas from Netflix, right? These are very natural hierarchical metrics-based systems. So I like the metrics endpoint, but when I move this application to production, I want to make sure that the service knows how healthy it is. So I can go to the actuator and go to the health endpoint. And this is an endpoint that's been in Spring Boot for years, ever since 1.0, ever since 0.6 or 0.4.0, right? Spring Boot's actuator health endpoint is very simple, and it's inspired by a number of other projects, not least all DropWizard, which had this idea as well, right? It is an endpoint that says how healthy the service is. It reflects HTTP 200. If you curl it, you'll see HTTP 200, unless there's an error, in which case you'll get a 500, right? And it'll show you in the output there, it'll show you just an aggregate status, but if you want, you can expand the details. You can actually configure it to show all the details about all the subordinate systems in the application that might have failed. So, and any one of which should cause the application to shut down. Well, let's suppose that your data source is not connecting, the validation query is not responding. In this case, the status would be down. This is a very natural concept, but in Kubernetes, there's 2 very specific concepts called a Liveness Probe and a Readiness Probe. A Liveness Probe is a probe that teaches you it teaches you whether the service is live, whether it's healthy. It's the same thing as the actuator health endpoint. It's basically the same behavior. So I've configured these 2 probes. I said health probes enabled, right? And so you can point your deployment to your Kubernetes deployment to this endpoint for the Liveness probe, and you can point it to this endpoint for the Readiness probe. Now, the Readiness probe speaks to whether the service is ready to start processing traffic, whether it's ready to be put into the rotation. That's evaluated when the application first starts up. Okay, so readiness is really about, should it be out in service or not, right? And health, the liveliness is different, right? And you can toggle this stuff. This stuff is yours to control. So let's suppose I wanted to build another endpoint here called down, okay? And I'm going to build a new handler function. And here, server response.ok.body, and I'm just going to return, okay, whatever. Let's see, down, okay? Just a string, who cares? But once somebody calls that endpoint, not very restful, mind you, what I want to do is I want to change the state of the Liveness probe. So I'm gonna inject my application context here, application context, AC, and then I'll say this, and then I have to pass in a subtype of availability state, in this case, liveness state dot broken, right? So I'm gonna pass in, I'm gonna publish an event, an application context event, and that's gonna reverberate throughout the application context, and then everything in the context that depends on that can then respond to that, right? So let's see here.
I have another question for you.
Yeah.
So if the actuator has its own thread pool, does that also apply to the HTTP health endpoint? We've seen it where the actuator is slow to respond when it's too busy.
It might be that it's pulling something, right? There might be something that it has to query, but yeah, the health endpoint itself should have its own thread pool. So I could be wrong, but last I checked, that's the case. I've seen it be slow because something else, like it was trying to pull some source, some downstream thing to get the state, and that in turn was slow, right? So that's one possibility. And that's one reason, by the way, I like this event context, this application context event mechanism. Components tell the endpoint when it's down, as opposed to the endpoint having to pull whether something is down, right? So if you can make sure all your components emit an event and tell, and then use that. Otherwise, yeah, I don't know. It's hard to speak to your precise thing, but it should be a separate thread pool, or at the very least, it's a configurable option. I'm pretty sure it's a separate thread pool, though. It was when I checked last. So I don't know why exactly you're seeing that. Does that help a little bit?
Yes, thank you.
Sorry. Where was I? Right. Oh yeah. So I'm gonna send a message to down, and we'll publish that event, and we're gonna break our endpoint. Oh, let some air in. It's getting dark. Okay. So here's my actuator endpoint, and go to down. Did I not publish it? Oh, this is readiness. I want liveness. There. Down. Okay. So if I restart. So it's up right now, right? Go to the down endpoint. Now it says down, right? I published the event and that took it down. So you can control that. These are all new features in Spring Boot 2.3 and later. And once the service goes down, once the health liveness endpoint is down and it signals to the platform container that it's down, you can configure Kubernetes, how to respond there. You might even say, okay, well, if it's down for so many requests, so many subsequent requests, then take it out of the load balancer. And that's basically the default behavior. Once it gets taken out of the load balancer, though, your platform doesn't necessarily have to kill it. Kubernetes, for example, has a grace period. If you still have any in-flight work, you might want to finish that work before the application gets destroyed, before the pod gets destroyed, right? Just because it's no longer in the ensemble doesn't mean it's no longer running. It's going to take a little bit longer to kill it because the platform gives you a grace period. And if you want Spring Boot to not immediately dismantle everything as soon as it gets a kill command, if you want it to like drain any work that it's got in flight off and then shut down gracefully, you can enable that with this new feature called graceful shutdown. So shut down, instead of immediate, it can be graceful. And we can specify the timeout. And here I want 30 seconds. Okay, so if I have any in-flight work and I have to simulate something that's long running, but if you have any in-flight work, let's see what happens. Well, I wonder if I can trigger it from here. Commencing graceful shutdown. Yeah, commencing graceful shutdown. Waiting for active request to complete. Unfortunately, there's nothing active. I don't have I should have created an endpoint where I simulate like a thread.sleep for like a minute or whatever, or 30 seconds or 20 seconds. But anyway, that's what you would see, right? So that works in tandem with your platform as well, making it very nice in a production environment. That way, if you have any in-flight things that might fail or might get in a bad state if you kill them right now, you can now make sure those finish off. So there's a lot of nice features, and now that we've got our application to move it to production. And I talked about configuration, I talked about the actuator endpoints, I talked about all this stuff. Let me restore. Well, actually, it doesn't matter. The next thing I'm gonna care about at this point is moving this application to production, right? And of course, for production, for a lot of us today, that implies containers. And so Spring Boot 2.3 and later, which is this version and later, comes packed with a nice feature where, thanks to something called a build pack, we can generate a Docker image for you. So I'm just going to run Maven Spring Boot build image, and then behind the scenes, that's using something called Paketo. Paketo is a tool from the Cloud Native Computing Foundation that, given a jar or .exe or Ruby on Rails program or PHP, I can't say it, it's not software. Given a Node.js or Vue.js or whatever application, all these things will turn into it'll take this thing and turn it into a file system that has everything that's required to sensibly run that thing, and then that file system gets turned into a container that you can publish to your favorite registry, Docker Hub or Google Container Registry or Harbor from VMware, wink wink, or whatever, right? All these things would be fine. But if you're using Java and you're using Spring Boot, well, like you saw, it's just done for you out of the box. Successfully built image. And this is now in my local Docker registry, and I can Docker push this to whatever registry I want. So I can say Docker run. And of course, keep in mind, this container is trying to connect to Postgres, and it's trying to connect to a config tree, both of which are running outside of the container. So you would need to set up -e environment variables and -v volumes for the config map. But you get the idea, right? There's my Docker container. It's upset about this not existing. Desktop config doesn't exist. So, okay. Lots of things that make it easy to move an application to production. I just showed you how that config map mechanism makes life a little bit easier when it comes to configuration. That said, there's nothing better than, as interesting as config maps are, and it's nice that we have a first-class citizen for that, in a construct for that in Kubernetes. There's nothing that replaces something as good as like Spring Cloud Config Server or Vault or something like that, right? So I prefer to use those. So let's now throw away all that, and instead derive our configuration from the config server. So I'm going to create a config server here. I'm going to go to start.spring.io, and I'll call this the config-server. Just call it configuration there, and configuration server. And I'm going to use Java 15, although it really doesn't matter in this case. UAO configuration.zip, and I think I'll sit down. All right, so we've got our config server up, and we want to configure that to talk to the configuration on my local directory. I've got a local machine Git repository. I think that's this. I want to talk to, a GitHub hosted Git repository. So github.com/long-crm-config. I'm going to point my config server to act as a proxy to this configuration directory. Now, keep in mind, this is wide open because it's a demo, and I want you to be able to reproduce what I'm doing. But you could lock this down. You could require a username and password or SSH-based authentication, and ditto for access to the config server proper. Right? Both layers can and should be secured. Let's see, configuration. Project PDK is not set up. Oh, it is now. Okay, here we are at enable config server, and we're going to configure in the configuration the Spring Cloud config server get URI equal that, right? So, and we want it to be on a port, particular port. So server.port equals 8888, and what else do we care about? I think that's it, isn't that? Oh no, the other thing we need to care about is the label, right? So There are some very good reasons for this, of course. The old nomenclature of master, which is, it has some very uncomfortable connotations for a lot of people. So GitHub very reasonably changed the default branch in new Git repositories to be main, not master. But as so much of the ecosystem still depends on master as the default, Spring Cloud included, Spring Cloud config server included for the moment, the default label is master. So if you don't plug in main, if you don't tell it, hey, you're looking at the main branch and not the old master one, it won't find it, and you'll be like I was, just very, very, very confused as to what's going on. So avoid that. Here we go. Start this up. Localhost 8888 and customers /default. Okay, there's my configuration for the customers endpoint. You can see it's coming from the customers.properties file, and it's a bunch of configuration that I want my application to have, including a database connectivity information and, of course, the port. So let's connect this to that. We need to connect our customers endpoint to that. So we're going to add this here. We're going to say spring.config.import, and we're going to bring in not the config tree, not the file system, not the class path, but a config server endpoint. In order to do that, we need to bring in Spring Cloud starter config, re-import, rebuild. Okay. And it'll be config server : we don't need to specify anything else because by default, Spring Cloud looks at this property called Spring Cloud config URI, and that is by default localhost 8888. So it's redundant what I just did, but just for clarity. Let's run this and see what we get. We should get everything we had before, but it'll be on port 8082. Okay, that's our first change. Good, everything seems to be fine. It's connecting to the database, 8082. The centralized configuration gives us a lot of benefits. It's now version controlled. That means it's auditable. It's easy to change it externally, and you can also use the Spring Boot refresh scope to reconfigure parts of the application in response to change configuration, rather than having to restart it as you would, for example, with a config map or a config tree based on a config map. So just a lot of really interesting benefits here. Okay, so application's up and running. It's got configuration. It's ready to go to the production. We saw how easy it was to create a container. The next thing I want to do is I want to create another service. Okay, this one's going to be called orders. And this orders one, I'm not going to use the database, but we're going to just create our own bespoke in-memory, quote-unquote, database, right, using just a map. And we're going to call this orders. So download UAO orders.zip. And here, we're just going to look at orders that belong to the customers. Now, keep in mind, the orders themselves they're not a subordinate. They're not part of the aggregate, right? They have their own life cycle. A customer might delete his or her account, but we need the order information for tax reconciliation, right? So these things, they map to each other, but they're not part of the same bounded context, okay? So my orders, let me get the configuration sorted out here first. Properties, orders, and voila. Okay, so my order service is going to have an object called an order, private integer ID, private integer customer ID, and it's going to be a data Norex constructor. And I'm just going to write some data to the database in this setup method. And when I say database, I'm using, I hope that you haven't, I hope that you can perceive my air quotes here. I'm just going to create a collection, a map of collection of orders equals new concurrent hash map. Yep. Good. So there's this, whoops. And we are going to write some data there. So I'm going to remember those IDs that I needed. Well, now I need them. Okay, so 85 to 92. So for var customer ID equals 85, customer ID is less than or equal to 92. Isn't that what I said? Yeah, 92, customer ID plus plus. And then for each one of those, I'm going to create an array list of orders. Order And then for each one of those, var order ID equals 1, order ID is less than or equal to some number greater than 0. Okay, let's say order ID. And orders dot add new order order ID, customer ID. Okay, and then just add this. We're going to say this dot db this dot db dot put customer ID orders, and voila. There's my little database. Okay, so very trivial. And now when somebody comes to this order service, they can make a request, a functional reactive request, header function, server response, routes, return route, build, okay, or orders, and it's going to be, of course, by the customer ID, new handler function, new server response, then okay, dot body, and the body value will be, of course, the result of calling the orders from the database. So we need to get the server request dot path variable. That's the customer ID. That's a string, right? But I actually want an integer. So what I'm going to do is I'm just going to do an integer dot parse int. Okay. And I'll use that here. I'll say customer ID. And we need to get the data. So here, var orders equals db.get customer ID, and I'm going to turn that into a reactive stream. So I'll say flux.from iterable, and I'll return that whole thing. So orders order.class. Okay, so there's my functional reactive endpoint. There's my handler function, replace that with a lambda, and restart. And this too will start up and get its configuration from the config server. Now I've got two services, I've got two microservices, and I want them to be able to find each other at scale, right? I want them to be able to find each other in a system. And so a natural thing to do here, what is the error that we have here, friends? Oh, that's the actual, okay, I know how to fix this. What I was just about to lead into this too. I kind of got ahead of myself. What I want is I want some way to easily find these services at runtime, okay? So by the way, did I delete everything here? What did I do for this? All right, so now that I've done this, now that I've got those IDs fixed, let's comment this out because I don't want all that other data being deleted since I'm depending on it being so configured, okay? So there you go. So now it'll still just be the same old numbers. So what I want is some way to easily find these services in my system. I can rely upon DNS, but not classic DNS. Like classic DNS, don't do that. Not a great idea. Classic DNS tells you where things are supposed to live, not if they live, right? That's very different. What I care about is if the service is alive and how many of them are there, right? So I can make smart load balancing decisions. Making a call to a service that is supposed to live at this hosting port, but that won't respond within an hour, that's not great. I want to avoid that at all costs. So you introduce a service registry. And Kubernetes, the Kubernetes API can be used as a service registry. You can just as easily use that as well as any other dedicated service registry. And the benefit here is that you can programmatically ask it for host and ports given a service ID or a selector in this case, in the Kubernetes context. So I'm going to show you a service registry, Netflix Eureka, but you could use the same Spring Cloud Discovery Client abstraction to talk to any number of different service registries, be it Netflix Eureka, be it Apache Zookeeper, HashiCorp Console, Cloud Foundry, Kubernetes, etc., or the aforementioned Alibaba NACOS, N-A-C-O-S, right? All of which will give you a configuration about where services live. Okay, so in order to do that, you need to have a service registry running. And the reason I use Netflix is because it's awesome, but it's also super easy to get it set up for a demo. And I am nothing if not lazy. So I'm going to bring in Eureka server, Lombok perhaps, and I'll just hit generate. And I'm going to open this up in the IDE. Okay, and same idea here. I just want to build a trivial thing. Obviously, you should secure this. You can load balance it, scale it out, lock it down, all that kind of stuff. There are well-known recipes for that. Or just use something else. Use console. Again, I have no horse in this particular race. So There you go. Server.port is going to be 8761. And I want Spring Cloud, Eureka, fetch registry equals false. And Eureka, register the Eureka is false. Okay, here's my basic setup. Let's go ahead and restart this. And with that done, I'm going to restart the customer service while re-enabling this. So I'm enabling the discovery client abstraction on the client there. Restarting that as well. So my service registry is here, and there are two services, customers and orders. You can see that they have this DNS entry called API. That's my local Etsy hosts, but it would have been 127.0.0.1 otherwise. The logical name is customers, and the port on which they can be found is 8082 and 8081, respectively. There's only one instance of each, but there very well could have been 10 or 1,000 or whatever, and so on. And there's also metadata. You can actually add custom metadata. This Netflix Eureka console was built for, well, Netflix, who have a very vested position in AWS, and in that region, in that context, it makes sense to have information about which AMI is running, which availability zone is running, and so on. But you can, of course, customize that. Okay, so here's my services. Now I want to build a thing to talk to them. So I'm going to go back to the initializer. I'm going to build a gateway, okay? And in order to build this gateway, I'm going to bring in Spring Cloud Gateway. And I think everything else I'll just leave in. I mean, why not? Okay, so hit generate. Gateway.zip. Okay. And as before, I configure this to talk to the gateway, the config server rather. So Spring Cloud config URI equals HTTP localhost 8888 spring.config.import equals config server : and of course spring.application name equals gateway. Now a gateway is logically a first port of call. It's a place where requests from the outside world can enter the system and then be either proxied through to a downstream service or to downstream services, or they can be finessed in some way. It's a great place to interpose cross-cutting kinds of concerns like routing, retries, rate limiters, etc. Right? So here in this edge service, I can use Spring Cloud Gateway and route locator. And Spring Cloud Gateway has a very simple paradigm. You say, okay, for each route, rs.path proxy, right? So I'm gonna say that whenever a request comes in to this service on port 9999, which is where this service is going to be running, right? Because it's got that configuration from the config server. Whenever a request comes in from that endpoint, it's going to hit the /proxy endpoint path rather, and it's going to be forwarded to localhost 8081. I could leave it like this, but first of all, there's no proxy endpoint in the localhost 8081. What I really want is customers, don't I? So maybe I do proxy, but then I want to, change it so that it's no longer proxy. The Spring Cloud Gateway API is going to take the incoming request, unadulterated, and forward it, proxy it to the downstream service. And I can change what it does before it does that by using a filter. So I'm going to say customers. Okay, so fs set path customers, localhost 8081. Okay, not bad. So that's one option. Is I can add filters. I can do all sorts of things here. I can add HTTP headers. Right, so access control, allow origin, etc. There we go. That's an option as well. So lots of different options here that I can use to manipulate the request as it's coming in. I can add rate limiters, right? You can use a Redis-based rate limiter to enforce that no more than so many requests per second hit a particular endpoint and that are forwarded on to a downstream service. I can protect them from being overwhelmed and so on. The Spring Cloud Gateway abstraction, of course, builds upon the Reactive Streams API. So all of this is reactive. Now, I like this idea. Obviously, I could send it to a particular host and port, but I don't want to do that. I want to send it to a load-balanced ensemble of services. So I'm going to instead use the load balancer prefix. That's going to be aware of my Spring Cloud Discovery Client abstraction. It's going to programmatically ask the abstraction for any of the available services instances, and it's going to forward the request to that downstream service on my behalf. That's very cool. So now I've got my Spring Cloud Gateway endpoint. Let's run that and see what we get. Okay. Now, of course, Spring Cloud Gateway is a great way for doing cross-cutting kinds of things, but I have other things I may want to do that are I might want to change the data, and this is actually where reactive APIs really come into their own. It's one of the wheelhouses. So before we get into that, let's take a look at what we just did. 9999/proxy. There's proxy, and as I make a request to that downstream endpoint, it goes immediately to the customer service, and I get the response lightning fast, right? Very, very convenient. Now, there's also something you can do without a line of code, right? And I've already done that by virtue of the configuration here. So if I go to Gateway in the Spring Cloud config server, you'll see that in that config server, I've got a locator enabled, right? So the discovery locator enabled is true. And what that means is that I can go to localhost 9999/customers, and I get the data. So customers in this case is the service ID, and this is the actual path. And ditto for orders, right? Ditto for any other service in the service registry. What did we say? 90. Right. So there we go. So that automatically proxies everything. So maybe all I need to do now is add access control origin headers, and I can point my JavaScript and maybe add security, Spring Security, JWT, OAuth, HTTP Basic, whatever. You can point your Angular app, or your Android app, your iPhone app, your Vue.js application to this endpoint, and you're off to the races. You've already got something going, right? So there's a lot of things you can do here. A lot of things they can do with Spring Cloud Gateway. But like I said, sometimes you want to do something more. Sometimes you want to have a view of some data, some materialized view. So let's suppose that I create a CRM client, okay? And this is just going to be a Spring Bean. And it's going to return a list of all the customers. Get all customers. Okay. Class customer. Class order. So order. These are the two DTOs. These are the types from the other services, right? I'm going to do something terrible. I'm going to basically copy and paste code. So don't do that, obviously. Customer ID, private integer ID, and private string name, right? So those are my two DTOs. Okay, so there's my customer responses, and I'm going to use my non-blocking reactive HTTP client called web client to make this request, HTTP, okay? In order to have an instance of that, I need to build it up. I need to actually vend an instance of that non-blocking reactive HTTP client, and I can do that by injecting a builder here, and I can use the builder. I can say b.build. Now, the thing is, I want my client-side load balancer plugged into this as well. So I can plug in a filter that's already pre-configured for us. I just have to plug it in to make sure I'm opting into it. And once I've done that, it'll now allow me to make requests of the following format, right? So I can say require X constructor, and then I say return this.http.get.uri HTTP customers, right? Customers. So I'm actually making my host in this case is the service ID. The data that I'm expecting back is a type customer. And there you go. There's my single endpoint. Okay. What about the other one for the orders? Okay, let's do that. So order, get orders for integer customer ID. And I can say return this.http.get.uri HTTP orders customer ID. I can pass in the ID here. Customer ID is a parameter. And the data that I get back, I'm going to retrieve it and body to Flux order.class and so on. Okay, so there's my stream of results as well. All right, good stuff. So now I've got my stream and I'm making calls to downstream services. And in this case, I'm hoping that the load balancer will have, the service registry will have one of the instances that I need. And if it doesn't, I still want to handle that errors. So there are several primitives that I can use that are built in to these reactive types, right? So one thing I can do is I can retry, or retry 10 times, or retry 10 times, but also have a back off, right? I can add a back off of 1 second. I can also specify a an error handler, like we talked about earlier. What happens if something goes wrong? I can just return an error. I can return an empty stream or whatever. I can degrade gracefully. So if a service isn't working for whatever reason, that's okay. As long as the client doesn't know that something's gone wrong, then it's fine, right? High performance organizations embrace the reality that things will fail and they build accordingly. Okay, so what if something goes wrong, or what if it's just taking too long? Well, of course, I can plug in a timeout. I can say I want to do a timeout of, let's say, 20 seconds. But here, we've got a bit of a problem. Timeouts are not a great way to guarantee that a client gets a response within a certain bounded window. They're a pattern of last resort, if you're asking me. The reason is because they don't actually give us the best guarantees, right? One pattern that I quite prefer over a timeout, which you can do, is it's trivial to do it, so you can definitely do it. There's no reason not to, but it's just not the best way. And so one of the things I like to do is something called hedging. So let me go to a little workspace here where I can actually write some code. Let's suppose I'm calling a service, right? It's called the string service or whatever, okay? And it's just some service downstream that has data that I want. Let's suppose that that service in turn calls another service. So my service depends on this first service called whatever, the one that I'm about to make a call to, okay? And that service in turn depends on another. So we've got 3 nodes that are in communication. The first depends on the other, and the second depends on the third. Let's suppose that the outermost layer, my service, has a ridiculously indulgent SLA of 30 seconds or 20 seconds, okay? Ridiculous, an eternity for computer time. So I have 20 seconds in which to produce a response. So I need to make sure that I get what I need from my dependency within enough time so as to either produce the response or cut bait and try again before I've run out of my time. So that means that if I've got 20 seconds, the thing on which I depend has 10 seconds. You see the problem here? And what about the thing on which it depends? Ditto, it has 5 seconds. And the thing on which that thing may depend, 2.5 seconds. This becomes untenable very quickly, and it gets worse and worse only by virtue of the proximity to the origin of the request that the service has, right? That's a really unfair situation. And it doesn't actually buy us that much. It gives us one extra shot to not screw it up, right? So a much better pattern is to use something like hedging. And with hedging, you rule out the risk at the same time as you're getting the right response anyway. So you can instead of dividing by 2, you can just keep your SLA, right, at whatever it is, at 100%. So let's suppose, and the way this works, hedging, the way this pattern works, is it's just good old age-old advice, right? Don't put all your eggs in one basket. Hedge your bets. Don't diversify the risk portfolio by investing in multiple stocks, that kind of stuff. It all means one thing: don't put everything in one possible outcome. So what I want to do is I'm going to call 3 distinct instances of my service, right? My logical service is called, let's say, the customer service. But I've got 3 different instances of it, right? I've got host 1, that's a different pod, a different instance, a different whatever. I've got host 2, it's a different pod, different server, different whatever. And I've got host 3, right? I could have 5, I could have 10, it doesn't matter. It's just some subset of the available instances, ideally more than 1, but less than, let's say, 100, right? You just need some, you don't need that many. So you pick some subset of all the instances and you launch them all in concurrence at the same time. You make the same request 3 times. This is wasteful, of course. It's wasteful, of course, but it's better than not having the response, right? And consider how fast reactive APIs are. It's not that wasteful. The only thing you got to be careful of is you shouldn't do this on endpoints where you don't have the ability to guarantee that the endpoints are idempotent, that there are no otherwise observable undue side effects, right? If you have side effects, not great. This is not going to be the pattern for you, right? This should be read-only kinds of stuff, right? If you have side effects, this is not the pattern to use on the charge the customer credit card endpoint, obviously, right? So do that, keep that in mind. But I'm going to say I want the first one to respond. I want to keep that one, right? There you go. So I'm going to launch all 3. Just wherever you see null, imagine it's a pipeline like I've described down here, right? And instead of me plugging in the load balancer, I'm plugging in a manual host import by myself. I'm using the reactive discovery client, right? So I've got the reactive discovery client, rdc.get instances, customers, and I can then map over this SI, and you can see that I've got the host, I've got si.get port. So now you can programmatically ask for distinct instances. It has to be, you don't want a dogpile in the same instance. So you need 3 distinct instances, right? But once you've got that, then you can launch those calls and get the responses. So this is a very natural pattern that you can do with reactive APIs that would be very hard to do without reactive APIs. And it's a pattern that Google uses, it's a pattern that Netflix uses, that Uber uses, etc., to allow them to guarantee certain results within an SLA. Very, very useful pattern. It wouldn't be fun or even feasible for most people to write it without reactive APIs. Imagine trying to write that code using threads and countdown latches and whatnot. It would be a nightmare, right? This is not fun code to write. Remember, there's only one person who truly understands how to write reactive code, how to write truly effective multi-threaded Java code. And I don't know who it is. It's not you, right? It's not me either, certainly. It doesn't matter who it is. I just have to believe there's at least one person. The point is, it's not for everybody, right? You're going to hurt yourself. Don't do it. Use structured concurrency. Move up the stack a little bit. Let the abstraction do the work for you. In this case, reactive APIs will do this for you. You get the most efficient, most reactive, most thread-safe code while also getting the result you want in less lines of code, right? We like that result. So going back to this now, going back to my services, my clients here, I've got 2 different clients. And what I want now is an aggregate type. I've got orders and I've got the customers. What I want is a materialized view over both. Right? So remember, these things have their own life cycle. They might very well have their own database, right? They might have, the orders might be stored in Neo4j or whatever, and the customers might be stored in Postgres, or maybe the other way around, or whatever, right? The point is, these microservices have their own state. And so I'm reading the data using these reactive HTTP endpoints, right? So list of orders. And there's my aggregate type, my DTO, that's going to describe the aggregation of these 2 things. And now I want to create a CRM client endpoint, or method rather, that gets me, that materializes that view of both data. So here, obviously, I'm going to be doing some scatter gather service orchestration and composition, right? So I'm going to say, give me the customers. That gives me a stream. And for each customer, what I want to do is map over the customer. I want to create a container for both the customer on the left and all the orders for the customer on the right. So I'm going to use one of my favorite operators here called Flux. And Flux takes 2 parameters, one on the left, one on the right. The one on the left is just going to be a single valued mono that contains the customer that we've just been given. And the one on the right is going to be the orders, right? It's going to be the orders given the customer ID. And I'm going to materialize that into a list because this is not an infinite stream of things. So I just want to have that there. Okay, so now, what do I have now? Well, I have a publisher, a stream of tuples of customer of list of order. So a tuple is this is a tuple 2, so it has 2 typed positional arguments, but you have tuples 1 through 8, and then after that you have to dynamically iterate. There's no a priori awareness of the type system, right? So now I've got this. I'm home free, right? I can say map tuple to a new customer orders, and I can say tuple.get T1 is the customer, tuple.get T2 is the link of orders, list of orders. So there's my stream of customer orders, right? And that's it. That's the entire thing. I've just done this very natural, very trivial kind of scatter-gather kind of orchestration with reactive APIs, all by using the operators here, right? And obviously, this is a lot to look at, but consider that that's how I would write it, right? And indeed, I wouldn't even necessarily need that first variable there. So we could just do this. We could say, there we go. That to me is much easier to kind of parse. I'm getting the orders, sorry, getting the customers, turning each customer into a zip, and the zip contains 2 streams. The list returns a mono of list, and this is a mono. It's a mono of customer. So I have a mono of list of order, and I have a mono of customer. They're both reactive streams that will produce at most 1 value. And what zip does is it takes 1 from the left stream, 1 from the right stream, and emits both in a new aggregate or accumulator type called a tuple. And so all I'm doing is I'm saying, for all the tuples that are going to come out of this previous thing, which you and I both know are going to be just 1, one tuple, right? For all the tuples that come out of that, turned into a customer orders object, right? Okay, so let's try that out. Let's see what that looks like. Let's create an HTTP endpoint to see that data. So router function, server response, build, COs. Okay, server response.ok.body. On the body, of course, is going to be informed by the response from the CRM client. So I'm going to say CRM client.get custom orders, custom order.class. Voila. Okay. And import. Very good. There's my CO's endpoint. Let's go ahead and restart this. And this will give us a read-only view on these two different things. Now, keep in mind, I've got one endpoint that gives me all the customers, and another one that gives me all the orders for each customer. So that's an N+1 problem, right? I'm making a call to the orders endpoint for every single customer that I get back. Not great, but and hopefully you would design your endpoints where you can, give it a collection of customer IDs, and it would give you back all the orders broken down by customer ID. Maybe that would be nice, right? If you have some control or some say in that, that's better. But even in this case, this is actually the least problematic version of this code, right? And the reason is because even though I'm doing an N+1 thing, it's not serialized. I'm not getting customer 1, then going to the orders, customer 2, then getting the orders, customer 3, and then getting the orders. I'm getting all the customers, and then at the same time, launching in concurrence threads to go get the orders for each one of those customers. And so it's lightning quick. So let's see here. Which endpoint did we call it? We called it COs, right? So localhost 9999 COs. Did I do something wrong? COs, get customer orders. Fine. I said lightning click just as I was made the fool. Get all the customers, orders, customers. No signal. So let's make sure my other services are happy. Customers, configuration, orders. That's the ticket. Oh, right. It's trying to call orders 151. Did I screw up the logic in there somewhere? 85. Okay, so what customers do I have? That's the issue, friends. Oh, darn it. 149 to 156. I didn't delete that code in time. So we go here, 149, 156. I should have used H2. I knew I should have used H2. Remember, I was even deliberating whether I should just use H2. That way the values would be fixed. It'd be recreated every time. It would start from 0. Okay, well, fine. No problem. We've got this. Here we go. So assuming you actually have endpoints to which you have responses, here's how you would get, again, I can request that all day long, really, really fast. So customer 149, here's all the orders for that customer. If you can see the foreign key there, kind of. 150, etc. Right? So very, very convenient, scatter together kinds of service orchestration and composition, easily enabled through reactive APIs. Now, this is great for reading data, okay? And it's HTTP. I like HTTP, right? I'm reading data over HTTP. But that said, HTTP is not necessarily the best way to communicate data over the wire. What I want is something that gets around some of the severe limitations of HTTP, something that supports bi-directional communication, something that supports potentially long-lived long-lived connections, something that is stateful, something that is multiplexed, something that has, unlike WebSockets, something that has headers, something that gives me the ability to do what I want, agnostic of any particular payload encoding, something that has information about the state of the service, the health of the service. We've been using the Spring Boot Actuator, but that's a convention that the Spring Boot and ecosystem has built, not necessarily something we can take for granted inside of HTTP. And so I want something that gets us further than what these things give us, right? And there's a really nice technology called RSocket. Now, RSocket gives us the ability to communicate data over the wire in a binary protocol. It supports bidirectional communication. It gives us information. You can make a request response just like with HTTP and HTTP2, but you can also do fire and forget. So kind of like a message queue where you send a message in and you don't care to acknowledge the receipt because you know it's in the broker. It doesn't matter where it goes from there, right? Or you can also do streaming where you can send a stream of values in and get a stream of values out. So lots of different opportunities there. I can rewrite any of these endpoints to be RSocket controllers, right? So let's do that here. Let's create a quick controller here. And we're going to create an RSocket endpoint here. Message mapping. And these are called orders, right? So orders, customer ID, publisher of orders, get orders for destination variable, integer, customer ID. And here, same idea, I'm just gonna get that, okay? Much easier. So that's actually an RSocket controller as opposed to an HTTP controller. In order to make that work, I need to start up this application, RSocket server port on, let's say, 8888. Okay, that's good luck. So I'm creating the same endpoint, just two different ways. Okay. Now, RSocket was designed by engineers who came from Netflix who went to Facebook, and it was designed to solve the scale issues of building services at that kind of scale and with that kind of robustness requirement. RSocket, the protocol, is platform and technology agnostic. You can use it from Java or JavaScript or anything else. What did I just do? Oh, 8888 is already taken, of course. Does 7777 work? Huzzah. So it's designed to solve some of those limitations. It was built after HTTP2 and gRPC came around, right? Because with gRPC, you're still dealing with request response, and you're still dealing with protocol buffs, right? Protobufs, which is not great. So there's some limitations there that they wanted to get around. RSocket, I think, is really nice. It's a protocol as well. So it's payload agnostic, platform agnostic. There are different bindings in different languages for different clients. The Java client, the Java binding, was built on top of Reactor. Oh yeah, this is also natively reactive, unlike, say, for example, HTTP. Imagine what happens when HTTP, a reactive HTTP service, has a client that connects to it and then disconnects midway. What happens there? Well, the best that we can do from the Spring WebFlux perspective, the reactive web runtime that you've seen me using this entire time, the best we can do when we perceive a client has disconnected is to cancel the stream that was involved in producing the response destined for that client that just disconnected. All we can do is disconnect, right? We can cancel and apply transitive back pressure one time. But we can't do that over and over. We can't just say, I've requested 10 records, the client is disconnected, but I'm not going to throw away I'm not going to throw away the state yet because HTTP doesn't have that idea in the protocol. But RSocket does. So with RSocket, imagine I'm streaming data. I'm looking at a feed of information from some sort of social network, and then I travel through a tunnel and I lose my signal. If I get to the other side of that tunnel and I'm using HTTP, I've got to start the whole request again. There's no way to pick up where I left off, right? With RSocket, I can just say, okay, I want the next 10, please, because there's no implication that the thing is gone. And also, with RSocket, your services stay connected. Your client and your service stay connected for the life of the application. So you can reconnect if you want, if something goes wrong. But they stay connected, so it makes it much faster. There's not constantly making network call, ACK, and then disconnect and all that stuff, right? Okay, so here's my RSocket endpoint. Let's consume that RSocket endpoint from here, from my gateway. Oh, this is the original error, yeah, of course. So clear that. So for my RSocket endpoint, I'm going to create an RSocket requester. Okay, RSocket requester. rsocket requester.builder. And notice that this is not an rsocket client. And the reason it's not a client is, again, because once these things are connected, either side is either a service or a client or both, right? There's no such thing as purely client, purely service, right? So they can do either thing at any time. Either side can initiate the conversation at any time. So there's my rsocket requester. Good stuff, right? So now I have rsocket requester. Let's create. You know what? Actually, I'll use that rsocket requester in my CRM client here. So private final rsocket requester. And here, which endpoint do we call it? We call it orders, right? So that's the orders endpoint. So instead of using the reactive HTTP endpoint, I'm going to use the rsocket endpoint. So I'll say publisher order get rsocket orders for integer customer ID. And what I want to do is I want to get the data using the rsocket requester. So it'll be called orders. And then I want to provide a customer ID. Okay, customer ID. The data that I get back, I'm expecting to be of type order.class. There we go. That's my rsocket call, right? So I'm not sending any data in except for the parameter, and I'm expecting data back. Very, very trivial API. And now I can rewrite this. And again, because even though they're two different protocols, they're just publishers at the end of the day. They compose very nicely, right? The APIs are the same. Basically, the experience is the same. You're just dealing with publishers all the way down. And the difference is that with rsocket, I can also do asynchronous streams. I could have an rsocket connection that sends data across the wire every second for the next week, and it wouldn't be a problem because I'm not keeping a thread open. I'm not blocking a thread at any point on the wire there. So there's my rewritten to take advantage of rsocket endpoint, right? And there's my service. So now I've got the ability to talk to different services in different protocols. You can see it's very easy to compose these things. I'm using HTTP and rsocket, and I'm doing a lot of reading here. But for my last little trick here, I want to make sure that we understand that for writes, you need to think about it a little bit differently. Writing data, I wouldn't want to be in a situation where my writes relied upon me making an RPC call to the downstream service, right? I want, in this case, to be able to take advantage of messaging, right? And there's a lot of different uses for messaging. Martin Fowler had a great blog a few years ago called What Do You Mean by Event Driven? And what do you mean by event? In this blog, he talks about 4 different types of messaging uses. Event notifications, where you communicate the fact of a change in the system state through a message. So not the actual details of the change, but the fact that it has occurred, right? You say, hey, consumer, check, repoll or requery your source of truth because the facts on the ground have changed and you need to know about it, right? Something has changed. You'll figure out what it is yourself. That's event notification. Event carries state transfer is where the consumer is given not just the fact of the change, but the change itself, right? The data that has the delta, right? That's the state transfer. There's more chatter in the wire there, more network chatter, but it's also easier for the consumer because they don't have to pull the upstream thing to get the information. Event sourcing is this idea that your entire system state is the result of replaying every event that has ever happened in the order that it has happened, and you should arrive at the same state, as long as you can replay each event. And if you understand the idea and the goal, then you can understand that we naturally need to keep track of all the events. And so we can keep them in like a stack, basically. We can replay them top to bottom. So there's different event sourcing infrastructure. You can even use Kafka kind of like an event source as well, right? Because it has this kind of stack approach. And then, of course, CQRS, again, this doesn't, strictly speaking, imply messaging, but it falls out naturally from messaging. It's this insight that if you separate the readers from the writers, if you distinguish them in terms of their implementation, interesting things happen. I might have a view, as we've seen here with the CO's endpoint, that gives me a materialized view of multiple things from which I'm reading. But when I write to these different services, I'm not going to have a unified view. I'm going to have 2 different things that need to update their own state. The other distinction that you get from CQRS, the other insight you get from CQRS is the fact that each service keeps their own view of the world, their own materialized view. So my order service is using, as you know, a concurrent hash map, which is a little trivial, but you get the idea. And the other thing is using a SQL data store. This reflects the reality of the world, right? Something might be using Elasticsearch, something might be using Postgres, something might be using MongoDB, right? Whatever, it doesn't matter. The point is that's up to each individual service to maintain and update. You're not communicating with their database, you're communicating with their API. And so we can embrace this pattern, this idea, this paradigm of tell, don't ask. What we're going to do is we're going to tell the order service and tell the customer service that something has been deleted, okay? And it's up to them to make the accorded changes to reflect that reality, right? And we can do that using messaging. And so we have an abstraction on the class path called Spring Cloud Stream. And what we're going to do is we're going to use Spring Cloud Stream. I think I've enabled it. Did I, or did I disable it already? Spring Cloud Stream, there it is, Spring Cloud Stream, and RabbitMQ and Spring AMQP. They're all enabled on this one. We also need to enable them on the other ones, of course. So that's the customer's endpoint. Let's go to the orders endpoint. And AMQP is there. Binder AMQP, RabbitMQ, good, good. Let's leave that there. Good, so now in my gateway, I am going to delete, I want to tell the downstream services to delete the data, okay? And I'm going to do this by using Spring Cloud Stream. Now, Spring Cloud Stream uses a programming model that comes from something called Spring Cloud Function. And so where's my config? Here we go. So with Spring Cloud Stream, I use the Spring Cloud Function API to tell it what supplier I'm going to use to produce events. Those events will then be delivered to the backing broker of my choice. I'm using Spring Cloud Stream and RabbitMQ, but there's no reason you couldn't use Spring Cloud Stream and Kafka, or Spring Cloud Stream and Google Cloud PubSub, or Spring Cloud Stream and Redis, or Spring Cloud Stream and Azure Service Bus, or Spring Cloud Stream and, I'm sure I'm missing some. There's like 5 or 6 out of the box that are there. There's a JMS one, actually, I think, or a JMS broker that has a Spring Cloud Stream binder. There's a lot of interesting opportunities here. All I'm trying to say is we're going to use Spring Cloud Functions programming API, the Surface API, which is basically just Java util function dot supplier and consumer. We're going to use that, but we're going to bind it not to a function as a service offering as Spring Cloud Function would normally do, but we're going to bind it instead to a Spring Cloud Stream managed destination in the broker. And that all lives in configuration. So the programming API, the only connection here is the name of the bean to the configuration. So I'm going to create a supplier, a Java util function supplier of a publisher of integer, where integer is going to be the IDs of the customers that are going to be deleted, right? So in order to do that, I need we talked about this before, right? We said syncs many.multicast on error back pressure. I want a sync of integer, private final customer deletions. Okay, so there's that. And when Spring asks for a publisher of messages to deliver, I'm going to return that, right? So that's the API. That's the entire messaging code. All I need now to do is to put an integer into the stream, and I can do that right here. So server response.ok .body. I can say customer deletions .try to emit this value, and the value, of course, is going to be the parameter that's going to be in the request in the delete command here. So customer ID bar customer ID equals server request .path variable customer ID. Okay, try emitting that customer ID. Oh yeah, I gotta make it an integer. So integer.parseInt. Okay, so I'm trying to emit that. That gives me a thing that I can ask for the success or not. Right, emit result or emit result, and I can say collections singleton map, and the value on the left will be the customer ID, and the value on the right will be whether it's succeeded or not. So emit result is success. Okay. So there's my updated delete endpoint. And now we want to update, before we start this and get it running, let's now update our corresponding consumers on the other side to do the right thing, to delete thing in the appropriate way. And so for those, we've got another bean, a consumer bean, called customer deletions consumer, right? So here in the orders endpoint, bean, consumer, publisher of integer. Okay, turn new consumer. And here you can either describe a consumer of type integer, or you can describe a consumer of type flux of integer. I'm describing a flux of integer, so that means I get a stream, a reactive stream of IDs. And for each ID, I want to take the CID, the customer ID. For each one of those, I want to delete the data from the database. So I say db.remove CID, and then that's it. I'm going to subscribe. Okay. Now I also want to log, just for ease of understanding our demo. I'm going to log what's happening. So I'll say on each CID, deleting orders for customer ID number CID. Okay, that's the updated code. There you go. We refactor that. So we want to do something like that in the other one as well. So let's restart the order service and then go to the customers endpoint and restart this. So now I've got customer deletions consumer here. I'm going to use the repository, aren't I? I'm going to use customer repository. Customer repository dot delete by ID, and then CID. Okay. There you go. There's my rewritten consumer there. We should be able to see, if I go here, localhost 9999/COs, and then what was the customer ID that we had? Orders, customers. Oh, the RSocket endpoint, because we disconnected. This is why you want to use the RSocket hub to act as an intermediary. Okay, so I want to know. Where's mine? Nobody gets deleted but me. There we go. Okay, I'm ID 154. Goodbye. Doesn't exist anymore in this one. And you can see reflected here, deleting orders for customer ID and deleting orders for customer ID. So we're using RabbitMQ and Spring Cloud Stream and the functional API and the reactive API to send a notification. We're telling each service with a command, we're telling it to delete its own state, to accommodate the fact that the system no longer believes there's an order, a customer called number 154 with the ID of number 154. All right, my friends, we have gone through just a little bit of stuff today. I wish we had more time. I wish we could really get into it, but we're just, I think we're gonna have to wrap it up here. I'm starting to get hungry. I'm still hungry. I've been wanting to barbecue all this entire time we've been talking. I've been thinking about barbecue. I want to thank you all for hanging out with me today. I know that there's a lot of places you could have been today, but you chose to hang out with me, and I appreciate that. And obviously, I wish that we could all be hanging out together. It's a weird time of year, weird time of life, but I'm grateful for the opportunity. I'm happy to answer any questions now. I want to thank you for being here. I hope you all taking care of each other, stay safe, wear a mask, all that stuff. That said, I'm very happy to engage in questions and so on here. And if you don't think of a question now, don't hesitate to reach out to me, Josh Long, or at StarbucksMan on the Twitters. I'm more than happy to engage there, okay?
Yes. There's a little bit of delay, but we thank you a lot for the presentation and joining our Java Kansas City group.
My pleasure, of course. Let's do it again. Any questions at all?
No, just a bunch of thank yous.
How do I even see it?
It's in the chat to the right.
Oh, there it is. Hi. Okay, comments. Whoa. All right. Thank you so much, everybody. Well, I appreciate it. I will. Let's do it again. You know, it's been a weird year, huh?
Yeah. All right. Thanks a lot.
Good night. Happy Thanksgiving if you celebrate.